Hey there, and welcome. You know, one of the best parts about programming, one of its real superpowers, is making the computer do all the boring, repetitive work for you. And that's exactly what we're going to dive into today. We're breaking down loops in Python. They're the absolute key to automating just about anything.
Okay, so imagine this. You need your program to say hello 5 times. You could just write it out like this. That's easy enough. But what if you needed to do it 100 times? Or heck, 1,000 times? I mean, trying to type that out by hand, it's not just mind-numbingly boring, it's practically guaranteed you'll make a mistake somewhere.
Well, yeah, of course there is. And here's the golden rule, The second you catch yourself writing the same code again and again, that's a giant flashing sign telling you, hey, use a loop. It really is the better way to handle any kind of repetition.
All right, so let's get into it. First up, we've got the for loop. And the best way to think about this guy is like an automated to-do list. Seriously, you hand it a list of tasks and it just plows through them one by one until the job's done. Simple as that. So the fancy technical term for this is a determinant loop, which is just another way of saying you use it when you know the exact number of repetitions from the get-go. Just think of it like this. Process these 10 photos, or find the average grade for these 50 students. You know the exact number of times you need to do the work. Okay, so how do we actually tell the for loop how many times we want it to run? Well, the go-to tool for this, the one you'll see all the time, is a super handy built-in function called range.
All right, pay close attention here, because this is where the magic really happens. So, first up, look at range 10. When you just give it one number, Python's smart. It starts at 0 and counts up to, but, and this is super important, not including that number. So you get numbers 0 through 9. Now, check out the next one, range 1, 10. See, with 2 numbers, you're telling it exactly where to start and where to stop. But again, remember, it always stops right before it hits that last number. And then there's my personal favorite, the third option. This lets you set a step. So, range 2, 15, 3 means start at 2, count up by 3s, and stop before you hit 15. This is what gives us such awesome, precise control over our loops.
So let's put this into practice. We've got for in range 5, 0, -1. What we're basically telling Python is, hey, create a number, let's call it I, and for every single step in the sequence that starts at 5, goes down towards 0, and takes steps of -1, do this next thing. And that next thing is just to print I. So what happens? The first time through, I is 5, and it prints 5. The next time, I becomes 4, and it prints 4. And it just keeps on going like that. And boom, here's the result. The loop did its job perfectly, counting down 5, 4, 3, 2, 1, and then, only after the loop was totally finished, it printed that final blast-off message. It's so simple, clean, and best of all, completely automated.
Okay, but what happens if you don't know how many times you need to loop? Well, for situations like that, we have another tool, the while loop. And I love this analogy for it. Think of a while loop as a vigilant sentry, a guard on duty. It's not counting items off a list, nope. It's just waiting for a specific condition to change.
Right, so this is what we call an indeterminate loop. That just means it doesn't run for a set number of times. Instead, it just keeps going and going and going for as long as a certain condition stays true. The very instant that condition becomes false, bam, the loop stops.
Now, the way this thing works is absolutely crucial to understand. I want you to think of it like a bouncer at a club door. First, Python walks up to the bouncer, the condition, and checks it. This happens before a single line of code inside the loop ever gets to run. If the condition is true, the bouncer says, okay, you can go in for one round. The code runs once, and then it gets kicked right back out to the front of the line to check with the bouncer all over again. And this is key. If that condition is false from the very beginning, the bouncer just says, nope, and the code inside the loop never, ever runs. Not even one time.
So this brings us to a really important question that every programmer faces. You've got these 2 different tools for making things repeat. How in the world do you know which one to pick for the job?
Well, here's the key difference, the main takeaway. It really just boils down to one simple question. Are you counting something or are you waiting for something? If you know exactly how many times you need to do a thing, like say, do 10 push-ups, you're going to use a for loop. But if you need to keep doing something until a specific event happens, like keep doing push-ups until you're tired, that's a job for a while loop.
Okay, so theory is one thing, But let's see where the rubber meets the road. Let's look at how these loops actually make our program smarter and more interactive. Let's send them out on a real-world mission.
So, a classic job for our vigilant sentry, the while loop, is something called input validation. Basically, it's about making sure the user gives you the kind of input you actually need. Because let's be honest, you can never trust a user to type in what you want them to. A while loop is perfect for this. It can just stand guard and refuse to let the program continue until the input is exactly right.
Okay, check out this piece of code. The condition we've set is while userinput.lower doesn't equal quit. What this means is the loop will keep going as long as the user hasn't typed quit. And trust me, this loop is going to be relentless. It's going to ask for input, check it, and if it's not quit, it'll just ask again, and again, and again. It absolutely will not stop until the user finally types quit. It's a simple pattern that lets us build really solid interactive programs.
But wait, there's more. Our control over these loops doesn't just stop at setting them up. Python actually gives us some really cool, precise ways to manage what's happening inside the loop while it's running.
So, let me introduce you to the break statement. The easiest way to think about this is like an emergency exit for your loop. The moment your code hits the word break, it doesn't just finish the current lap. It's game over. It busts out of the entire loop right then and there. And this code here is a perfect example. So the main while condition says, hey, keep looping as long as I is less than 6. But look closer. There's an if statement inside that acts like an override. The second that I becomes equal to 3, that break command gets triggered and the whole loop just shuts down. It's done. It doesn't even matter that the main while condition is still true. Break is like pulling the fire alarm. It's the ultimate get out now command.
And all this talk about stopping loops brings us to a really, really important warning. You see, with all this power comes a big risk, a classic trap that every programmer falls into at some point, the infinite loop. This is what happens when a loop's condition is set up in a way that it can never become false. Just take a look at this code right here. The loop is set to run while not done, and since done is false, that condition is true when we start. But here's the problem. Look inside the loop. Do you see anywhere where we change the value of done? Nope. It's exactly like that little guy on the treadmill. He's running and running, but the scenery never changes. Nothing inside the loop is ever changing the done variable, so that condition will always be true. This program, if you ran it, would literally run forever, or until you shut it down.
And so that really leaves us with one final crucial thought. You know, we've been thinking of our loops as these amazing hard workers, right? They're either efficiently checking items off a list, or they're that vigilant sentry, patiently waiting for a signal. But we have to remember it's our job to always give them that stop signal. Because you have to ask yourself, what happens when your vigilant sentry is told to stand guard, but you never, ever give them the signal to stop?